Okay, so we're going to finish up density curves and normal distributions by determining if the distribution is approximately normal. And how do we determine that? So, in lesson 2.2, last little section here, we're going to say, do we have normal test scores? So for chapter 1 test scores, there are 80 test scores that come out for the AP Statistics students. And with this distribution of these test scores, are they approximately normal? And we need to justify our answer using several different approaches. So, to determine those, or to determine if it's approximately normal, you need to do 4 things. So we're going to start out with saying we're going to graph, all right? Graph. Now this graph doesn't have to be all these, but one of these, right? You can say a dot plot. So you do a dot plot. You could do a histogram. You could do a stem and leaf. Or you could do a box plot. Okay? So you can do one of those to determine it for your graph. The second thing you need to do is compare the mean and the median. So compare mean and median. All right. The third thing we want to do is think about, does that third standard deviation away from the mean, does it make sense? So does the third standard deviation away from the mean make sense? Does it make sense? Does it fall within a data value that is probable, that we're actually can be attained? So that's what we're going to look at for that, for the third step. And the fourth one you would want to do is check for the 68. Oh my goodness, if I can write 68 here, let me write that a little bit better. The 68, 95, or 99.7 rule. Okay? So determine if that all makes sense to where the data values fall within 68%, 95, 99%. Okay? So we're going to check those 4 things out. Now I made this a little simple and quick and easy here. So if we're to look at this, I'm going to zoom out just a hair. So I did this setup for the first setup. We're going to look at the graph. Whether you do a dot plot, a histogram, a box plot, or a stem and leaf, right? If you did any of these. And you can see the shapes look a little different for the most part. I mean, this first on the dot plot kind of looks like maybe it could be almost like skewed a little left. Same thing with the histogram. Alright, kind of going, could be symmetric. It's not too apparent to be skewed left, but it could be. And then same thing with our box plot. As you can see, the median is over this direction. Yet you have this other data going this way. It's a further setup, further stretch compared to the stretch going to the right. So that almost looks like it could possibly be skewed as well. Don't use a box plot to determine if it's skewed or symmetric, but that is kind of apparent with the way that's set up there. And then you have your stem and leaf, which looks pretty symmetric. If you were to rotate that 90 degrees to the left, counterclockwise, that would look like a pretty symmetric setup. So the stem and leaf looks even just regular symmetric. So that's at least starting off with talking about approximately normal. So even though these dot plot and histogram, they look a little bit skewed left, then for the most part, it's not very apparent. If you see something skewed left or skewed right, it's going to be very obvious. It's going to be like, wow, that is skewed left, or that is skewed right. These are pretty close in data range. You're just going from 60 to 90 for the most part on your data and whatnot. But we're going to check to see if some other things work out. So anyway, at least drawing one of these graphs would be the initial start. And then we say we're going to compare the mean and the median. Well, our mean is 80, our median is 80. Well, that means 80, they equal, right? So if that is the case, didn't we say when we were drawing these for normal distribution that the mean and the median are pretty equivalent for normal distribution, for symmetric distribution, right? Okay, so that one kind of checks off for sure with looking like a normal, approximately normal distribution. So with our graphs, one of our graphs, they're working pretty good with that. Then we have this set up here with our compare mean and median. Definitely falls in line with being approximately normal. Now, does the third standard deviation above the mean make sense? Well, with this, let's go ahead and take this data right here and put it in here for a second. Because now we're going to look at this as far as 3 standard deviations. We're going to draw this out. All right, and we have our mean is at 80, and our standard deviation is 9. Okay? So if we have that, that means we're going to have 89 for 1 standard deviation away. 2 standard deviation away, it should give us 98. And then 3, if you add another 9, this will give you 107. So 3 standard deviations above the mean. Well, unless we had, shall we say, some extra credit on that test or whatnot, that third standard deviation is kind of not obtainable, right? But there's nothing wrong with that, because that would mean that from within 3 standard deviations, remember that 99.7% of the data should fall between 3 standard deviations. So pretty much all the data should fall within there. So let's see what it is if we go the opposite direction. So if we take that, and what are we looking at? We're looking at 71, right? And we're looking at, will that be 62? And then what, 53? So between a 53 and a 107, all that data should fall. Well, the minimum score we had, if you look at this, the minimum score we had was a 57. So we had a 57 for our min. So we don't even go past 53, so that's good. And our max was a 93. So in this case, all of our data falls between 3 standard deviations. So yes, it does make sense. Yes. Because all of our data falls between 3 standard deviations of the mean. I should word that a little bit different. Between 3 standard deviations below and above the mean. So therefore it's showing that it's going from -3 to +3. So that does make sense for the standard deviation setup. And again, that's going on, checking on the actual 68, 95, and 99.7 rule, which does exactly what we just talked about, right? We pretty much just answered that as well. So for checking that rule, that falls into what the statement we just made, right? So yes, this rule makes sense too. This all works out as well because we have everything falling within 3 standard deviations plus or minus of the mean. So all data falls oh goodness within 3 standard deviations plus or minus of the mean. Okay? So with looking at that, it's pretty straightforward, right? As long as you check those 4 off and make sure that those all work, then we've got approximately normal distribution of our data. Now, if you're able to have a TI Nspire, it makes it even easier because you don't even really have to do all that stuff, right? So with this on the TI Nspire, there is an actual check to see how this plays out all together. So this, I'm sorry, this is the actual normal probability plot. Okay, so that's a normal probability plot. To get this, under your spreadsheet for your TI Nspire or TI-84, I'm sure I need to work on that to see what the actual commands are for it. But with this, on the TI Nspire, I listed them all under the spreadsheet here. Okay, so all 80 scores, oh my goodness, I got super fast. All 80 scores are right there, okay? When you do that, if you do Control and Doc, which is a plus page, you would allow yourself to do a number 5, add data and statistics. Down at the bottom, you want to click, I label by column test or the test scores. And it gives you your dot plot, right? Now you can simply hit menu and where's that? Plot type, I'm sorry. Plot types. So number 1, plot type, and hit normal probability plot. And it draws exactly what we got. I'm giving an equation for the line there, okay? With this, we have that. Now, if the normal probability plot is fairly linear, which in this case is fairly linear indeed, the distribution of these test scores, chapter 1 test scores, is approximately normal. So again, if normal probability plot is fairly normal, I mean linear, then the distribution of chapter 1, don't forget your context, chapter 1 test scores is approximately normal. Okay, so if normal probability plot is fairly linear, then the distribution of chapter 1 test scores is approximately normal. So if you're able to use this calculator and you can sketch this graph and make this statement, then that takes care of the normal probability plot. So again, make sure that you can graph, compare the mean and median, check your 68, 95, 99.7 rule, and you could also check your normal probability plot if you needed to, okay? And let's see. And also to determine as far as the third standard deviation away, if it makes sense. And then for the normal probability plot, make sure to make this statement and sketch your graph for the normal probability plot, okay? So again, we have for these setups, you want to graph, compare mean and median, does a third standard deviation away from the mean make sense, and check your 68, 95, and 99.7 rule. Alright guys, so that should take care of determining whether the distribution is approximately normal. And that finishes up 2.2. I'll see you next time.